Hi guys, welcome to week 4 lesson 1, our second last lesson on algebra. Yay! Today's lesson is on difference of perfect squares, also known as DOPS. Our learning intention is to understand what a difference of perfect squares is, to be able to expand brackets to form a difference of perfect square, and to be successful for this lesson you need to know what DOPS is and to be able to expand to form a DOPS. So, a difference of perfect squares is similar to a perfect square, but instead, this time we have 1 plus and 1 minus. So, similar to a perfect square, but with the difference of one's a subtraction, one's a thing. So difference also means subtraction. So just remember that little thing is that when we say difference, we're meaning we're subtracting. So if we expand this guy here, we end up with a squared minus ab plus ba minus b squared. Now if we look at our like terms, so ab and ba, just remember that as long as the number out the front is the same, it doesn't matter if the letters are the opposite way. So these are our like terms. So we've got a negative plus a positive. So we only end up with, at the end of this, a squared minus b squared, because these two guys here cancel out. And that is literally what a DOPS is. You can have it going a minus b and a plus b, and you're still going to get the same result of you're going to have a squared plus ab minus ba minus b squared. And you're still going to end up with those two like terms cancelling out to have only a squared minus b squared. So the result is a difference of perfect squares. Because if we were to put a number or a variable in here, you're going to have one minus the other. And that's why they call it a difference of perfect squares, because we've got one perfect square, take away another perfect square. So the result of expanding one of these, where you've got both same things in both brackets but with a plus and a minus, is called a difference of a perfect square. So the good news is they are predictable. You are always going to end up with an answer that looks like one of these. And if you notice, they're exactly the same. So let's do an example so you can see what I mean. So let's say we're just going to expand and simplify. So when it means simplify, that's where we collect our like terms. So our first one will be x plus 2 and x minus 2. Really? You want to join in too? Okay. Sorry. So let's expand. So just to remember, we're going to go x times x first, which is just x squared. It's going to be minus, because if you look at our next one that we have to multiply by, it's got a minus right in front of it. So minus 2x. We're then going to go 2 times x, that's going to be a plus. And then you're going to end up with a minus, because you have got a positive times a negative. So then minus 4, because 2 times 2 is 4. Okay, so look, find our like terms. So our minus 2x plus 2x is our like terms. At the end, we have x squared minus 4. So for those of you who are wondering, but where's the other square? So if you look at here, it's a bit like x squared minus 2 squared. Okay, but we just simplified by evaluating, meaning finding the answer. So we just went, what's 2 squared? So 2 times 2 is 4, and that's where our final answer came from. Alright, so then we've got, let's do a second one. Now this one's a tiny bit more complicated because they've turned around and you've got a number in front of our variable and we've got two different variables. So if you look here, we've got 3x minus 2y and 3x plus 2y. So we're going to do the same thing. We're going to go 3x times 3x. So 3 times 3 is 9. X times x is x squared. Okay? Then we'll do our 3x times 2y. So this is going to be a plus because there's a plus there. So we go plus, 3 times 2 is 6, and x times y is just xy. Okay? So we then move on to our next part. It's going to be minus first because we've got a minus in front of our 2y. So minus. We go 2y times 3x. So 2 times 3 is 6, and x times y is xy, or it could be written like this, yx. Doesn't matter which one you do. We're then going to end up with minus, then we got to go 2y times 2y. Okay, so remember 2 times 2 is 4, y times y will give you y squared. Underline our like terms, so we've got 6xy minus 6yx. Both like terms, the letters are just rearranged because they're mean. Okay, so we're going to end up with 9x squared minus 4y squared because those two middle cancel out. And that's pretty much what we're doing with dots. So I'm going to give you guys a try it yourself to do. Have a go. Email me your answers and then move on to your assigned work. So you are still expanding, by the way. These two, for reference, follow the exact same pattern as the examples we did just before. So if you follow the step-by-step you did there, you should be fine. So good luck, and I will talk to you next lesson.